Okay, in this section, we're going to talk about how corresponding parts of congruent triangles are congruent. For example, if you're given two triangles, ABC and DEF, and you are told that the lengths of AB and the lengths of DF are congruent. That means they're equal. AB and DF are equal. I'll give them one slash. And we're also given that the lengths AC and the lengths EF, they're congruent. AC and EF, they are congruent. And we're also given that CB, the length from C to B or B to C, is the same as the length DE. These two sides are equal. Notice I give them the same number of slashes. I give two sides, one in triangle 1 and one in triangle 2, the same number of slashes if they're congruent. So this is what is given. And we want to prove, for example, that angle B is equal to angle D. Okay, so statement and reasons. Well, the first statement will be all of this. Just put it there. Again, if your teacher says you need to list the givens individually, well then call them statement 1, 2, and 3. Okay? It's the givens. I mean, write it down. So the reason would be given. Actually, let me have some more room for the statements. So this is given. Number 2, we can say that triangle ABC is congruent to triangle so 1, 3 FDE. The two triangles are congruent. Why? Side, side, side is congruent to side, side, side. They both have the same sides. Alright, now the next thing we can say is that angle B is equal to angle D. Angle B, which is right here, it came from side AB, it's made up of side AB and BC. More importantly, it's made up with the side that has one slash and a second side that has 3 slashes. It's between 1 and 3 slashes. But that's exactly angle D. It's made up of this side and this side. 1 slash and 2 slashes. So they're corresponding parts. Corresponding parts of congruent triangles are in fact congruent. And that's done. So basically, to use this corresponding parts, a congruent triangle is a congruent, first you have to conclude that the two triangles are in fact congruent. So if you have a figure like this, A, B, C, D, and it's cut like this, and if you show that AD, so this is the given, you're given that the length of AD is the same as the length of BC, so there it is, And you're also given that DC and AB are the same lengths. DC and AB are the same lengths. Then we can then these are congruent triangles. And I'll state why in a moment. And then we can show or prove that angle B and angle D are equal. Statement, reasons. First one, write down the givens. These two. Put it right there. And of course the reason is this is given. Now, statement 2, you say that AC is congruent to AC. Identity. Identity. Length is equal to itself. Okay, so these two are equal. Well, we have two triangles, the one around number 1 and the one down here. That is, we have this red triangle and we have this green triangle. But congruent, because each triangle has the side with one slash. Oops, there's a typo here, I'm sorry. AB and DC were equal. Well, for DC on the top, I put 2 slashes. I should have put 2 slashes for AB. Okay, so the red triangle has a side with 1 slash, a side with 2 slashes, and the side with an X. So does the green triangle. It has 1 slash, it has 2 slashes, and it has the X. These two triangles are congruent. So statement number 3 will say that triangle ADC is congruent to triangle BAC. And the justification, the reason is side, side, side is congruent to side, side, side. And now number 4. We can say that the corresponding parts are equal. And we'll justify in a moment why they're corresponding, but assume these are for a moment. Why are they equal? Because corresponding parts of congruent triangles are in fact congruent. Now, why are B and D corresponding parts? Well, angle D is made up of 2 sides. Every angle comes from 2 sides. And these 2 sides are the side that has 2 slashes and the side that has 1 slash. That's what makes up angle D. But angle B has that same property. It's made up of 1 slash and 2 slashes. The side with 1 slash, the side with 2 slashes. So we prove that angle B equals angle D by corresponding parts of congruent triangles, saying that they themselves are congruent. If 2 triangles are basically the same, well, then they have to have corresponding parts. We have a circle, the center is O, and you have a diameter which crosses the center, and you have this vertical radius. You have a diagram like such. A, O, B, C. And you're told that CO is perpendicular to AB. And you're also given Okay, and right off the bat, excuse me, so that's what you're given, and you want to prove the following. That AC is congruent to BC. So, again, AC is in the left triangle, BC is in the right-hand triangle. So somehow we want to get these two triangles to be congruent. So again, let us be real clear what the two triangles are. There are actually three triangles. The two that I just highlighted and the big one, ABC. Okay, so I want to show that the two smaller ones are congruent. So you have the statements and the reasons. And like always, the first statement is going to be what's given. CO and AB are perpendicular. Given. Well, what that tells us is that those two angles are equal. That tells us that those two angles are equal. Angle AOC and angle COB are right angles. Two perpendicular lines meet at right angles. Number three, angle AOC is congruent to angle COB. All right angles have the same lengths. All right angles are congruent. Okay, so we have two angles are equal. Now, AO and OB are equal. They're both a radius of the triangle. Okay, so while we're at it, I'll even say OC. AO, BO, and CO are all radii. Any line from the center to a point on the circle is a radii. A line from the center to any point on the circle is a radius. So now in statement 5, I'm going to say that BO is congruent to CO. And there's something wrong here just with the silly numbering. Sorry. Okay, now all radii are equal. All radii of a given circle are equal in length. Okay, so now I have where I put the 1 slashes. Now I want to say that CO equals CO. Actually, I don't even care that it's a radii. I didn't even have to include it in statement 4. It's not wrong, I'm just not using it. Statement 6. CO, length CO, or line segment CO, is congruent to line segment CO. And this is because identity. But now what we have is, we have these two triangles are congruent by SAS. Between the two sides is that angle. Between the corresponding, between the two sides is the angle. S, angle, and then S. So number 7 would be that, let's see, okay, so number 7 is just going to be that the two triangles are congruent. Triangle AOC is congruent to triangle BOC. BOC. And the justification is side angle side is congruent to side angle side. So now the two triangles are congruent. And if I may, I'll finish up the statement reasons here. So now I can just say that AC is congruent to BC if they are corresponding. And here, they're both opposite the right triangle. They are not the side that has this AC, it doesn't have 1/ or the X. BC, it doesn't have 1/ or the X. It's that remaining side. Okay, so those correspond. Corresponding parts of congruent triangles are congruent. They're both opposite the right angle. There's only 3 sides of a triangle. If there were 4, we would be in trouble. But there's only 3 sides of a triangle. One is marked with 1/, one is marked with an X, and the third side, it has no marking. Well, that's the same in the red and the green. So the ones with no marking, well, they correspond. That problem is done. So corresponding parts, that's all this is about. Let's try one more. Like circle problems. Suppose you have this big circle. It's centered at O. And you have A, B, and C. And let's see what we're going to use as the given. Okay, how about we're given that AB is congruent to CB? We want to prove the following. AOB, angle AOB, is congruent to COB. Okay, so basically I want to show that those two angles are congruent. Oh, okay, we're given that AB and BCB are congruent. So we have that. So statement and their reasons. 1, AB in length is the same as the length of CB. And this, of course, is given. Now number 2. This is very similar to the last problem. AO and CO, they're equal. Of course, they're both radii. AO and CO are radii of the same circle. Okay. Any line from the center to a point, PT is a point, to a point on the circle is a radius. Now, number 3 is I'm going to say that those radii are congruent. All radii of the same circle are congruent. Now, BO equals BO. BO is equal to BO. Is congruent to BO. Identity. And what I'm trying to say, maybe I should have said it a step ago, is that this red triangle and the other triangle, those are the congruent ones. Well, the red triangle has 3 sides, one with 1 slash, 2 slashes, and a side that has an X. The green triangle has a side with 1 slash, a side with 2 slashes, and a side with X. They're congruent. SSS. If I may come down here, triangle AOB is congruent to COB. Triangle COB. And the reason is side, side, side is congruent to side, side, side. Now number 6. Now I can state anything pretty much as long as they're corresponding. Angle AOB and angle COB, they're equal. The reason is AOB is this angle here. And in the within the red triangle, it's made up of the side that has 2 slashes and the side that has an X. But that's the same as COB, which is here. It's made up of this side, which has 2 slashes, and this side that has an X. So the reason that they are congruent is corresponding parts of congruent triangles are in fact congruent. Okay, so basically you prove that 2 triangles are congruent, and then you could then justify why 2 sides are congruent. But only if they're corresponding. That is, they're in the same type of location. If you were to rotate or cut out one triangle, you can put it right on top of the other. And if angle A of one triangle lies on top of angle D from another triangle, well, those angles are congruent. And if line segment AC lies on top of line segment EF, then those 2 line segments are congruent. Okay, that completes this section.